All right, thanks for showing up for my talk. I'm going to talk about insecurity of web applications. Basically, I'm going to talk about how we tested some applications, what findings we produced, and how people tried to fix it. And then we tried to unfix it, and then they tried to fix it again, and we unfixed them again. So you see, this talk could be a little bit ranty. Bear with me. I have an offensive perspective on those things. I'm a security analyst, and I indeed studied software engineering, but mostly only to break software and not to engineer it. So my perspective is pretty offensive. So it could get a little bit ranty from time to time. I don't mean to be offensive to the developers in no case. I know that especially web apps and corporate environments are hard, especially when it comes to security. So if you feel offended at some point, please approach me after the talk so we can, sort things out. Or fight it out in the outside, exactly. I have some code, pseudocode on the slides. This is obviously redacted, and it's not compiling at all what you see there, but to give you an insight on what the vulnerabilities are, what the fixes are, and how we attack the code again, to give you a little bit of insight. I'm not going to give a detailed technical advice on all of these things. I just want to give you a different perspective. This should not be the standard, this is the OWASP top 10 list and this is how you fix it talk. I'm trying to go one step further and basically show you what happened when people actually are confronted with our findings and how they try to fix it and why this fix is obviously a bad fix. So what I'm going to do is I'm going to give you some generic solutions and some directions that you can have as a pattern. Okay, I'll start with the classic one, Sql injection, one of the biggest ones. The application that we have tested is your usual PHP MySQL Linux stack. It has a bunch of unmaintainable code fragments laying around, sprayed around the web server, and we had access to the source code for white box testing. And the approach they took for dealing with SQL injections was basically the kill it with fire approach. They threw stuff on it that was redundant and didn't make sense at all. And there is a bonus one, which is, from my perspective, pretty hilarious. I don't know if you're going to laugh about it. Anyways, we'll come to that later. So Sql Injection Fix, what did they do? They tried to basically just find all the things that could be potentially malicious and then abort the script and print out an error message. And they did it basically like this. They searched for example, a select in the query, and then aborted the script and said there is something bad happening. So first problem with this is, I mean, it's bullshit, obviously, but like the generic problem with this approach is this is case sensitive, right? So you're actually searching for, with string position, you're searching for a case sensitive string in the URL. So what if an attacker actually supplies low characters that are lowercase, you will be easily able to bypass this. Okay, so what did they do? All right, they changed it. They used something that is not case sensitive. Oh, by the way, could you start this thing for me? Because I'm still at 26 minutes, which is good for me, but it's obviously bad for the next speaker. So, oh no. Can we go for 4? All right. So, yeah, so what they did is they fixed it in this way. Right, that's obviously also bullshit, because what you're doing is basically an approach like this as an attacker. So what happens here is that you have a cell, select, act. The select gets stripped out, and what remains from the string is a select, which is what you want as an attacker, right? So just hardcore searching for strings that could be potentially dangerous is in general a bad idea when it comes to stuff like SQL injection or cross-site scripting. Also, this doesn't find select less injections, right? So if you have a delete or an update or whatever, or an insert, you can also do an SQL injection. You'll have to take care of a lot of scenarios that you're probably not able to see when you're dealing with your code, because you have a different perspective, right? You don't have time for, like, I don't know, 5 days just looking at this code and thinking about how can you make this secure, right? This is actually also not your job to do it like this. And this is not at all generic, because you'll have to touch the code in certain points, think about what do I need to deal with here, and that's obviously not a good approach. So they thought, okay, we need some kind of generic thing. And they thought about, hey, what about replacing all of the blanks that we have in the potential attacker string with a special char like underscore or whatever. The problem with this approach is an attacker has more time to think about how to get around your countermeasures, and this would be a countermeasure where you have an SQL injection without using blanks, right? So this filter doesn't do anything right now. I can easily go around this filter with using /* as a comment, and this will be, at least for the MySQL PHP stack, MySQL will actually convert this to a blank and will say, okay, this is basically a separator, and the SQL injection will work. Same goes for sanitizing the input by handling special characters. I am not actually, this is like, in security we have this input validation manifest thing that everybody needs to do. I'm not a big fan, to be honest, of that, because it mostly tackles not the problems that the, I don't know, 60, 50, 70, maybe 70% of all of the classical web developers have. Because doing input validation in the right way without, like, you know, having a good software stack available. I mean, if you're developing stuff for WordPress, for example, or if you're writing WordPress plugins or stuff like that, you don't have your big Java application where you can think about creating, I don't know, wrappers and facades that actually aid you or guide you through input validation and checking, right? You don't have this available. And so input validation as like the silver bullet for cleaning out security bugs in web applications is not something that I would say is the #1 that you should take care of. It's a good addition. Yeah, okay, so I said that there's a bonus. Right? They tried to deal with SQL injections, we unfixed their fixes, and we found another thing, because what happened during this penetration test was that they actually were live fixing some of the SQL injections that we have not yet been able to detect, and they were fixing already some stuff, and we found out later that they were fixing some stuff. For example, this. Right? So what they do right here is basically they're getting the contents for an image file that is on a temporary folder, has a temporary name on the file system, and you're basically uploading your image, whatever, and then they're inserting this image as it is into their MySQL database. That's bad, because the binary blob of an image can contain single quotes, for example, which in turn breaks your SQL query because there is a single quote in the file content, right? And that's why they came up with a few fixes before we even found stuff, because they thought, yeah, that's actually bad. There's like certain images, if you upload them, they break the SQL query, and then the SQL dies, and the application dies. So that was pretty interesting to see that the developer in this case was not able to grasp the security potential that is actually behind this, right? If you see something like this, that your SQL is failing because there are some special chars coming from somewhere, you should be able to make the transfer to say, all right, there is probably a more severe problem than just our image upload functionality is breaking. By the way, same goes for abstraction query languages like HQL, for example. We also see stuff like this, where you have your SQL string, and then it's not supposed to be used in the right way. Is this string concatenation? People input or concatenate their input to this HQL query. The right way to do it would be like this, via set parameter, for example. So just saying or telling people use HQL or use some abstraction layer, then you're also fine. I'm only talking about the security perspective here, right? Then you're fine. Can also go wrong if you don't know how to use this and why you should be using it like this. Yeah, so the real fix, obviously, of this is use prepared statements or derivatives. Don't, rely on input validation, especially for SQL injection, because depending on what kind of database management system you have, what kind of dialect you're talking to your SQL database, your assumptions just might fail when you're doing your input validation and checking your input validation. But it is a good addition if you have easy cases that you can actually tackle. Oh. Thanks. So if you have easy cases, then it's a good addition. If you cannot use prepared statements, check what your current best practices for that stack is. I don't know if there is any web application language that is actually not capable of doing something, a derivative of prepared statements. Perl can do it. You should not probably not write web applications in Perl, but from my perspective at least. But Perl has them, maybe Bash doesn't, but who writes web applications in Bash? Do not reinvent the wheel. That's also a big thing, right? Don't try to be smarter as the attacker, because the attacker is going to invest far more time in breaking your stuff than you will be able to think about how an attacker could break your stuff, all right? Okay, cookies. We're talking about cookies. We had an application that was on an embedded device. Web application was written in C. It had a high spaghetti factor. It was a black box test. We were looking at this thing, and we saw that in the request there was a cookie set which was called MD5 login, and the parameter actually was the password in plain text. So this also happens in the year 2016. We found this. And the endpoint didn't even check the cookie, so you could just easily omit it. So this was basically just an insecurity feature, because you're transmitting your password in plain text in a cookie, and you're not even checking anything with this cookie. I have no idea how this went into the code at all. Probably I don't want to know this, but this is also stuff that we find. So we said, okay, this is probably bad. Come up with something better. More generic, and then using the plain text password as a cookie. And now they use the UUID that they were generating after the login, which on first glance sounds pretty good. But if you look into this UUID, if you gather more and more and more cookies, hundreds of cookies, actually you can even tell it by gathering 5 cookies, that this is not a good idea to do it this way, because it's basically sequential, and you can just brute force the next cookie that would have been set, right? So that's also a bad approach. Talking about cookie scopes, this is something that also goes into pen test reports that we give out, and it's probably annoying the shit out of most developers because they're thinking about why is this rated medium? You're rating it CVSS, you're trying to rate it CVSS. CVSS says, wow, cookie scope, oh my god, that's like a 10.0 remote code execution. Then we have to take steps in the report to explain, maybe it's not that bad, you could risk accept, but it's a best practice, look into it, please. But in this case, it was actually a pretty bad thing. So imagine there is like a multi-tenant Java portal with the tenants being separated by subdomains, right? And we went through this in a black box test, and it was basically just a portal.xyz. And the cookie that has been set for the scoping of the cookie that was set was basically for portal XYZ. That means that you can also authenticate to erandw.portal.xyz, but also to everything else .portal.xyz, because the cookie scope for the administrator was basically set for just portal XYZ. That means that the application, your browser is going to send that cookie, obviously, because it is also for this domain, and the backend system didn't do any checks and would have let you pass. So by logging into your tenant and then just specifying another subdomain, you were able to log into that other tenant because the cookie scope was basically wrong. And obviously the backend checks were missing. Yeah, so when we're talking about cookies, please use your libraries, right? Do not reinvent the wheel. You have frameworks, you have all of that stuff. Don't come up with, creating the cookies by yourself, basically. All right, same goes for access controls. This is another feature that I want, that's a nice feature actually. It's also going to pen test reports when we find this. It's probably annoying developers more than the cookie findings. It's called autocomplete. It's a feature for your browser when you're basically going to log into a web application and you don't have this turned off. Your browser will basically offer the user to save the login credentials. And most of our customers say, yeah, whatever, that's like, what can possibly go wrong, right? The browser will store the credentials, you'll have physical access to the box to actually do something with this. Why would we need to turn autocomplete off? I mean, this is the feature. You probably all know it. When you're logging in somewhere, it basically tells you, hey, do you want to save the credentials? If you're setting autocomplete off, it doesn't. So in this case, the administrative login basically used this feature. And the problem is how some browsers work, that they are basically, when you're using the autocomplete feature and you're saving your credentials in the browser will then, for the next login on the domain, look for fields that have the same name where you saved the credentials for. Right? So you're logging into, I don't know, user and password, that's the field names that you're used to log in. And the problem in this case was that there was a configuration somewhere on that web UI that had the same names. The form was the same form names, which means that when you're logging in with autocomplete, you're going through the web application, you're changing some settings, and then you're saving those settings. Then the browser will see, hey, I know this password field, I know this username field, this is autocomplete, so I'm going to write the stuff that I've saved, username and password, into that field and then submit it. And that's what basically happened in this case. In this case, it was a configuration for voice over IP devices. And you could basically, on the back end, log in, configure the devices, and then push the configuration to all of the devices, to all of the phones, to all of the voice over IP phones in the network. And what happened in this case was that once you got hold of this phone, there is also a username and password setting in there, and this now holds the username and password that you need to log into the application, because the browser was not only sending this for logging into the web application, but was also sending it out in that other form that had the same tag names, basically, right? So this was, for us, this was like, I don't know, since 13 years, I'm searching for a finding where I can say autocomplete off is really, really dangerous, and this is like the best case scenario that you can have, right? I mean, it's clearly an edge case, but it's a very interesting one because from the developer's perspective, it's like nearly impossible to think about that case, right? Because, yeah, autocomplete, we should turn it off, yeah, whatever, right? It's not a problem, so we're not doing this. And then you're basically pushing your username and password to all of the voice over IP phones in an unencrypted way, and everybody who has this phone can actually log into the administrative UI then. All right. Okay, next thing, cross-site scripting is something that we find everywhere, and I mean everywhere. And this is probably why we have so many additional workarounds or countermeasures, for example, cookie scopes, HTTP only, content security policies, whatever. So what we do when we're testing for cross-site scripting is we do a classic proof of concept, which is probably an alert box, right? Something's just popping up. So you have a visual that something's happening in your application that obviously should not be happening because there's JavaScript being executed like this. As I said, cross-site scripting is everywhere, right? I think it's still unfixed, but I reported it, so I hope that they're going to fix it in the next hours. Yeah. So, and we encounter a wide variety of fixes for cross-site scriptings. So our proof of concept is we pop an alert box. The fix is we blacklist alert. The unfix is we pop a prompt box. You can guess what the next fix is. The next fix would then be blacklisting prompt. We then call them and tell them that might be not a good idea, and they need to dive deeper into how cross-site scripting works and what the problems actually are. We find tags being blacklisted. We find a lot of blacklisted things that all don't work. It's pretty similar to Sql injections. As soon as you start for SQL injection and cross-site scripting, as soon as you start tackling this problem by yourself, you're basically lost. Especially if you keep in mind that this is valid JavaScript code, right? And this is basically popping you an alert box. So thinking about investing time in thinking about how an attacker could still break your filters and validations is basically senseless, especially for Sql injection and especially for JavaScript from my perspective. There are only, I don't know, a few cases that we have found where people actually, we saw in the code that people were actually taking care of those problems, they wanted to take care of those problems, and it actually worked what they were doing. Though in most cases, it simply doesn't work what they're doing. So don't try to be smart as the attacker. Yeah, input encoding sucks, especially for cross-site scripting, because actually you don't want to change the data that is coming in, right? So when you're dealing with, I'm not talking about your one-page PHP application, I'm talking about like a giant e-commerce Java application that has millions and millions of users and endpoints and forms. You don't want to change the data that is coming in, I mean, if you can, right? You want to work with the data as is, and you don't want to change it and substitute stuff and encode it in a form that when somebody else is getting it out of the database first has to look into the manual and how to decode it because he's going to render that stuff in the browser. So this is, from my perspective, I think something that for cross-site scripting is not working. And from a software engineering perspective, I just think it's a bad decision. Input validation is also a good line of defense if you can. If you need to invest, like, I don't know, 5 days in thinking about how you will be doing your input validation in this specific field for cross-site scripting, skip it and just go for output encoding and use well-known libraries that do the stuff for you, basically, right? So it's far more easier to, just by looking at cross-site scripting, now I'm just talking about cross-site scripting, just look into output encoding, appropriate output encoding, and don't try to sanitize input and work with the input. Yeah. So this is also a very interesting case. It has the nice, neat, small name, the unauthenticated, arbitrary, sanitized, not file download. You'll probably not get why this is the case even after I explain it. It's an application that is also your usual PHP, MySQL, or MariaDB Linux stack. It has a lot of unmaintainable code fragments in the web root, and some parts are like download scripts that you can use to download backups from the MySQL database and stuff like that. And a bunch of those scripts have no access controls at all. You just can call them. So we told them, okay, that's bad, especially for downloading backups from your database. You should have credentials. You should have like authentication or something. And then they said, okay, we'll just use the PHP scripts and put some hard-coded credentials in there. That should be fine then, right? So this is kind of the code. I'll try to walk you through this. So what we have is we have this get at the beginning with the file name. So this is the download, basically, right? And what it basically does is it has an array with 2 usernames and 2 passwords, 2 corresponding passwords. And if there is a username in the request, or a user, if the parameter user is set, then it's going to dive with this user into the array of users and see if the password that is in there is actually the password for that user. If this is the case, it's going to create a session and then let the user download the file. Okay. Problem with that is, what happens if you fire a request like this? This is a post request to download the file, and it just has the username set to an invalid username. What happens is that if you specify an invalid username, you're going into this array, PHP array. This user will not be there, and it will check if for this user that is obviously not existent, if there is a password. But you didn't supply a password, so both is null. And null equals null. That's why this is an authentication bypass, basically, right? And you're able to download all of their stuff. The second problem with this is that the get parameter file basically just gets rendered into the path that you can use to download stuff. So the next finding that we have is we can just use a path traversal and download files from the web directory without specifying a valid username or password. So they fixed this. They fixed the authentication bypass, and then they tried to fix the path traversal. So what they did is they take the file name from the GET request, replace // with nothing, and then replace from that // with nothing, and then return /backups and then the parameter file. That's obviously not a fix, because you're not using your new parameter file too that you just sanitized, right? You're using the parameter that was supplied to the GET request. We really, in this case, it wasn't the case, but we also saw something like this, where you have like, I don't know, 15 lines of sanitization, and then you're using your GET parameter unsanitized to do the stuff, right? We also see this stuff like this. In this case, they used the parameter, they used the file parameter that they sanitized, but I mean, it's an obvious question, is this fix working? Obviously it's not working, because this is how we unfixed it. So first of all, imagine this string above with the slashes and the dots. First of all, we're going to strip out the dot slashes, which results in this. Then we're going to strip out the dot slashes, which results in this. Right? So we could also unfix this. So that was basically the re-arbitrary file read. Yeah, okay. Exactly. So the real fix in this case is obviously use a generic authentication and authorization solution. Check your best practices. Minimal machine is extremely critical. Don't have a bunch of scripts laying around your server that nobody knows the name of, and nobody can actually, you know, have an idea that they're there, and we don't push them to production. Yeah, most of the times you do, maybe, and use common escaping techniques, so don't reinvent the wheel on those things. So I'm coming to the conclusions. Do not reinvent the wheel. If you have one takeaway from this presentation, then please this one. I mean, it's probably a bold statement, but I say input validation is not a silver bullet for web applications. Don't really rely on input validation in all cases, because input validation, you need to make assumptions where you may be not aware of the edge cases that exist for an attacker, right? And that's a problem. But it's a good addition, and it's a good, basically, first line of defense, right? If you have a giveaway like it is, I don't know, we are just dealing with numbers, try to convert it to int, for example, in Java, then you're good to go, because the Sql injections will probably not be possible anymore. But still, do not rely on this, and take appropriate measures for specific problems, okay? All right, but from my experience, which I find very interesting, bad security does not necessarily correlate with the skills of a developer. I've seen developers that are, from my perspective, very skilled developers, and they come back to us with questions. All right, now tell me about this SQL injection thing. What is this about, and how can we tackle it, right? I think this is a clear educational problem. I don't see that security at universities is actually done in the right way. Because what we don't need is more studies that are pure IT security, because those guys are not helping you. They're basically coming to us and then breaking your stuff, but that's not the holistic approach that we should be taking. I think that it would be a better approach to, if you're a second semester studying at the university software engineering, you should be able to get an intrinsic motivation to use prepared statements, for example, because you just learned it this way. How you just learned object orientation, you learn how to do this. And I think that there is a big gap on what can be taught security-wise to students, to the development branches of IT, basically, to what we actually could do. And I don't know how to tackle this problem. I think it's a big problem. I think this is the root cause why we have very good developers that are not able to grasp basic security patterns sometimes. Not all of them, but sometimes. All right, that's it. Thanks.
Thank you, Florian. So you managed to keep the guys in. Fantastic.
Yeah.
So on the questions, I think we have some questions again on Slido. Maybe we can put that up. So as MySQL query is depreciated, there is a new version PDO and a new environment. What about security flaws in there?
Yeah. So okay, I'll start with the first one. MySQL query is deprecated. Yes. I would say that in 75% of the cases that we see PHP code, MySQL query is still used, right? So that's bad, because think about what applications we see. We don't see like the big, shiny, 100 million users corporate applications. I mean, we also see them, but I don't know, 60% of the cases is like just web applications for edge cases where they have like a user base of 100 users and they need to integrate it into their internal network, and that's why they need a pen test, and then we basically find stuff like this still. Yeah, so my examples are not working anymore, that's true, but the only assumptions that they are not working anymore is that you're sticking to PDO. From my perspective, we're still not there. It's basically, maybe it's the same discussion as going for buffer overflows. I think buffer overflows, we have so many mitigations against buffer overflows, they're like all gone, right? Like 10 years ago, we had like, I don't know, DP, stuff like that, and you know, we have all of these mitigations. But still people are using it in the wrong way, still people are doing this, and I would say that MySQL query will be still there for a long time.
So what's the best story to tell? What's the best security issue you found? It's now number 3.
Probably it's cross-site scripting, but not because they don't get it, but because applications tend to get more complex. So we tend to find more DOM-based cross-site scriptings right now than like the usual reflected or persistent XSS. The XSS that you saw on the WeAreDevelopers side is also a DOM-based cross-site scripting. And this is pretty hard to tackle because your cross-site scripting knowledge, you need to basically adapt your cross-site scripting knowledge to JavaScript libraries. Most of them are doing the job right. Most of them are actually doing the thing for you already. But for some, you can still use them wrong. So this is basically, it's not a new thing, but it's a new thing for developers to use JavaScript libraries and also having cross-site scripting vulnerabilities in there. Are those slides available somewhere? Probably yes.
I think that can be quite easily answered.
Yeah.
Somewhere, yes. It's up to you to find them and maybe to break into your systems. Why not? Or maybe you're sharing them with us.
Yeah, I'm sharing them, no problem.
Thank you.
Yeah.
Thanks for that.
They will be somewhere.
Brilliant. That's
it?
Thank you. It's a pleasure. A round of applause.